One thing that we like to do when we run across a plane curve is to try to sketch that curve. One method for doing that is to sketch the curve from a table. So the directions: complete a table and sketch the graph. Our curve in this case are given by the parametric equations x equals t squared plus 2, y equals 4t, where the parameter t ranges from -4 to 4. So what we need is we need to fill out a table, as those are the directions, and then we can plot the points, the x and y coordinates, and sketch the graph, including orientation. So first we need to pick some values for t, and they need to range between -4 and 4. So the most straightforward ones to pick would be -4, -3, -2, -1, 0, 1, 2, 3, and 4. Nothing special about those except that they are in the interval from -4 to 4. So to do a couple of specific values, if t is equal to -4, then x, we are told, is equal to t squared plus 2. So that would be -4 squared plus 2. -4 squared is 16, plus 2 is 18. If t is -3, pardon me, we also need to find out the y-coordinate. So if t is -4, y, we are told, is equal to 4 times t. So y would be 4 times -4, which is -16. Now, we can put those into our table. So if t is -4, x is 18, and y is -16. If t is -3, then x is -3 squared plus 2, which is 9 plus 2, that's 11. And y is equal to 4 times t, which in this case is -3, so -12. We can put those into our table. So x is 11, y is -12. Okay, we just keep going. So if t is -2, then x is -2 squared plus 2, which is 6. And y is equal to 4 times -2. We're just taking each value for t, plugging them into the equations for x and y. So we can add those. 6, -8. Now t is -1. If t is -1, x is -1 squared plus 2, which is 3. And y is equal to 4 times -1, which is -4. So 3 -4 goes in our table. Okay. Maybe we could start doing some of these in our heads. If t is 0, then we would get x is equal to 2, and y is equal to 0. If t is 1, then x is 3, and y is 4. If t is 2, then we would have x being 6, and y being 8. If t is 3, then we get x being 11, and y being 12. If t is 4, we get x is 18, and y is 16. We can put each of these on our graph. Let's go ahead and take our graph, the scale of our graph. Each mark will represent 2. So we've got 2, 4, 6, 8, 10, 12, and so on. And in the y direction, 2, 4, 6, 8, 10, 12, and so on. So if we put our point x 18, y -16, we'll start here with the smallest value for t and increase t. So x is 18, y is -16. X 18 would be there, y -16 there. So this is 18, negative 16. Move to t equals negative 3, so we have x is 11, y is negative 12, so 2, 4, 6, 8, 10, 11, and negative 12, 2, 4, 6, 8, 10, 12, 11, negative 12. Keep going. Now, if t is negative 2, we have 6, negative 8, so 2, 4, 6, 2, 4, 6, 8. 6, negative 8. If t is negative 1, then x is 3, negative 4. If t is 0, then x is 2 and y is 0. Just plotting these points according to their x and y coordinates. If t is 1, x and y are 3, 4. If t is 2, x and y are 6, 8. I put this point a little too far. Let's put it where it really needs to go. That's 3, 4. And here is 6, 8. If t is 3, then x and y are 11 and 12 respectively. And if t is 4, then we get the point 18, 16. Now we can connect our dots with a smooth curve. If we think of this as a point moving according to t, say, being time, then when t is negative 4, then the point is down here at 18, negative 16, and the point travels in this direction until it reaches the point 18, 16. And to indicate some movement here, we can put arrowheads along our curve to mean that if the point were moving along this curve, it would start at the point 18, negative 16, and it would move towards the point 18, 16. So those are the two endpoints of the curve. This curve has endpoints which are distinct, so it is not a closed curve, and hence it is also not a simple closed curve. So here's an example of sketching a plane curve defined by parametric equations via a table.